Hey guys, it's Chuck. Channel's Outside Screwball, as you probably know since you're here, and just wanted to say hello and thanks for stopping by. It's Memorial Day weekend and a little different start here. I'm not in my machine shop. You see I'm out in my main shop. My wife's van is up in the air and you can see some car parts down there. I haven't been doing much machining lately. Had to put front struts in the van here, and it's been tying it up a little bit. The parts came and one of them was damaged. I had to resend it. So struts have been replaced and the car will be going for alignment. Other than that, as I mentioned in my shorts, I've been sick and finally on the mend and really haven't done much in the shop. One little thing I did do is I copied this tailstock adapter for my buddy Chewy, my mentor, and I made a part for a two-jaw chuck form. I made a tail piece form. I do have some video of that, and I may throw that in on the end here. But as I mentioned, it's Memorial Day weekend, and it's today's Sunday, and going to watch the Indy 500. Got that recording. It's kind of a tradition for me to watch the Indy 500, and but it's a special day also. We're going to go on a little road trip, a little field trip, only a few blocks away. But we're going to go to my buddy's shop, Carl, and he's going to show us his Gorton 3D engraver. And I've shot some footage of that, and I hope you guys will enjoy it. I think I certainly did. So we'll be back and go a little road trip. Well, hello guys. I'm over at my buddy Carl's shop here, and we're going to show you some parts he's making for a model engine. And what we have here on the screen is a 1/4-inch pipe elbow. That's right here, and we have 1/3 scale mock-ups of that, and that's what we're going to show you, is actually building these parts, scaling down from this 1/4-inch elbow. And these are about 3/8 of an inch is what that pipe elbow is, and this right now is almost about 7/8. It looks like. I could grab a scale. I don't have my scale holder here with me, but it's about 7/8 of an inch, and these are about 3/8 of an inch. And these are various steps that when Carl was working on designing these and making the tracing adapter work, different steps that he had gone through. So we're going to go ahead and show you set up on the machine, and I'm going to pull this into the screen here. Here's another pipe elbow that is the one that we're actually going to be modeling from. And again, it's a 1/4-inch pipe elbow. Okay, so we'll move on and show you here some more work in a second. Okay guys, we're over at the machine, and I'm going to turn over the discussion to Carl, and he'll handle the explanation on it.
Now you guys can see from the nameplate, this is a Gorton P1-3 three-dimensional engraving machine. Engravers will take a larger model or pattern and reproduce it at a reduced size to the work that you want to perform. Over here on the right hand side we have the 1/4-inch pipe nipple. This is our original or model or a pattern, you can call it any of them. And a stylus, which we'll show you later, will follow the contour of this elbow. The cutter goes over here in the spindle, and the motion of the stylus is transferred to the cutter through this mechanism. The whole thing is free to move like this and move in this direction. The ratio between the stylus and the cutter is set by a mechanism back in here, which may be a little hard to see. It's a fixed ratio. When you set it, the ratio of this machine will go from about 1:2 to 1:8, something like that. So 1/2 to 1/8 is currently set to reduce at a ratio of 1/3. We're going to go over to the workbench, and I want to show you next the stylus and the cutter, tell you a little bit about that, then we'll come back to the machine again. Hang on a bit.
Quick question, Carl, while we're here. What's the spindle speed, and is that adjustable?
The spindle is driven by this cotton belt from a motor and a set of shivs back there that you don't see. It is not adjustable in the sense it's not a variable frequency. It's fixed pulleys. This is currently running at about 10,000 RPM, and this machine will run, if I remember right, somewhere between 3,000 and 4,000 and 15,000 or 20,000, something like that. Depending on the size of the cutters.
Cool. All right. We'll be right back.
Okay, I use ball-end carbide cutters to carve that profile out of the solid. I begin with a roughing cutter, which is an 1/8 inch. The rule is that the stylus has to have the same ratio as the work, so the inverse ratio. The work is going to be at 1/3 size, so the stylus has to be 3 times the diameter of the cutter. So here is the 1/8 and a 3/8 stylus, a 1/16 ball end mill, and a 3/16 stylus. I tried using 1/32 inch cutters, and I snapped so many of them at $8 a piece that I said it's going to be easier to file the profile at the end than it is to buy cutters all the time. So the next thing we're going to do, we'll take the stylus and the cutters over to the machine, install them, and show you how the machine operates. Back in a bit. The next thing is to show you a little bit of the fixturing. There are 2 subplates, one for the pattern, one for the work. They carry on top of them the actual fixture plates that carry the pattern and the workpiece. The reason for this is that this plate comes off, goes over to the milling machine where I do this detail, this pocket that takes the body of the pattern, and this detail. The pattern goes like that. I need to be able to bring the pattern back and put it back in the same place, and then if I need to pick it up and do more work on it, I can take it off. That's the reason for the subplate.
And so you have positioning pins.
Yes.
For the subplate.
There's 4 dowel pins that take the position, and there are 4 of my home-built Mighty Bite type clamps that real quickly release and reinstall the fixture plate, and it goes back in exactly the same location. So there is the workpiece mounted on its fixture plate. Now we go over here. We have the same thing repeated, and that is a subplate and the workpiece plate. The workpiece plate was machined on this from here. I put a cutter in here, I put a stylus, and I cut from this groove, I cut this one, and from this groove, I cut this one, and from here, I cut this pocket. The effect is that this is at 1/3 size, but it is exactly in the same relative position as this. So now I can do anything I want here with the model, and I can do the corresponding thing over here with the workpiece, and everything will align from one to the other. Now Chuck asked me to say a word about the table motions of the machine. I'll call it the pattern table. This moves only up and down. We'll call that the Z direction, although I'm not really sure that's the proper one. We'll call that Z up and down. This is an XY table, which also has Z. I'm not going to move any of them because they're set for this particular job. One of the things I'll notice is that here is the hand knob, and it comes off of the lead screws. Once you have set the pantograph up for an operation, you take these off so you don't accidentally grab them and turn something out of position. I think that covers the machine. We're going to stop for a minute. I'm going to we got to do one more thing. That goes there, and the workpiece goes here. And I won't take the time now to clamp this down. When we come back, you'll see that these pieces have been clamped. I'll tell you a little bit. The purpose of all this is I want to be able to turn this over. I'm going to engrave one side, and then turn it over and do the other side. So the workpiece gets cut one side, turned over and the other side is done. We'll be back in a second.
Yeah, I'm just going to grab the workpiece and just bring it up in the camera since it's kind of far away, just so the guys can see it. And you can see its relative size to the pipe itself.
Yeah. Okay. Well, we came back a little early because I realized there's one thing I wanted to tell you about, and that is, of course, these plates are these are MDF, these are particle board, but look at this. I've tapped the holes directly into the wood. But what I do is I just drill and tap just like it's ordinary, and then I run it full of thin CA glue, and when that is set, I run the tap back in. For the level of force that I need to apply to this to hold it, these are entirely adequate. I don't have to put wood inserts in, I don't have to do anything fancy. I just drill and tap right into the wood. This is the setup step. The pattern has been clamped in its fixture plate. The workpiece over here has been clamped on its fixture, and the stylus and cutters have been installed. I have rested the stylus on the top of the highest point of the pattern, and over here I have brought the table with the workpiece up until the paper is trapped between the cutter and the workpiece. I'm about 2/1000 off. The process is going to be, I'm not going to refine this distance anymore until we have machined the whole shape, both sides. Now we're going to measure it, and once we've measured it, then we know how much more material to take off. So this is a roughing step, and we're going to stop here for a bit while Chuck takes the camera loose from from his tripod mount. He'll hand hold while I show you the process of engraving this piece. Okay, Carl's got the phase verter on and the machine's running right now. Go ahead, Carl. I'm going to set the first cut on the adjustment up here, and then we are going to, if Chuck will go over there, we are getting the first cuts on the workpiece. I pulled back while he's roughing there, and I thought I would try to get a little picture of how the motor assembly is tracking down here. We've all seen an end mill cut, so we don't have to watch all the roughing. So we'll come back. As he keeps going deeper, he keeps lowering there on his stop. So we will continue roughing so we get the start of the shape of the part so you can see it. So a little in-process shot here. As you can see, you're starting to see a shape of the pipe fitting there coming out of the aluminum block.
basically just whittling away, and again, you see he's actually not on the pipe right there. He was actually whittling away more of the actual aluminum block that's the part, and needs clearance so that he can continue to go down the radiuses of that pipe. Roughly depth to cut, Carl, per pass?
Probably 5 thousandths,
About
10
5
thousandths.
thousandths pass, yeah, maybe 10 at the most. And just back as he's still kind of whittling away, I guess would be the terminology to use here. We were discussing it off camera there, is that there's really no books that explain how to use this machine, and there's not many experienced people around these days that still do this. And there's not that many of these machines probably around, unless they're CNC, I would guess. But we were discussing that where we were talking about where he wasn't roughing the exact part, but he was actually milling the block down.
Right here.
Right, yeah, what he's doing right now. That really could have been done, the pattern block taken over and roughed out in the mill and move away the bulk of that material. But we're just doing this as a demonstration, and so we'll just come back. I'm going to try to get in here and get a little closer shot of the stylus following the part. Carl unfortunately has to get his hand up out of the way, and it's a little awkward. But you can see this is the 3/8 stylus that's following the part. Of course, you can hear the cutter in the background. So right now we've basically, the part is half milled. One half of the pipe is machined, and the part would be turned over to machine the other side of the part. So we're going to go ahead and pull it out so you can see it. And if you see these pins here, which come off the part, I was asking Carl what keeps the part from just shearing off, and then he mentioned that the pins are what's going to hold it when the part is completely cut, because the pins don't get cut. So there's the part machined, one half of it. It should roll at 90 degrees.
Oh,
right, yeah, right. So right there. So you can see the part cut, and then you can see how the pins are going to basically hold it. So he would end up, go ahead and it would just go back in the fixture, turned over, and the back side of the part, the other half, could be machined, and of course the pattern would be loosened and also turned over. So we're going to call it quits there. I really want to thank Carl for showing us this demonstration. I hope you guys enjoyed it. I've never actually, I've seen parts that he's built, but I never watched it in action, so I really had a little learning experience here and some enjoyment, and of course I get to spend time with my buddy Carl too, so that's always a plus. After we got off camera, I was mentioning to Carl, I came over one day and I saw that he was machining this blue material in the engraver, and you can see there's a pipe fitting in there. Well, he was doing it in machinable wax in the early stages of doing all the setup, and of course it's much easier to machine wax than aluminum, and you can see the scale differences here. The full scale, the third scale, and when he first started working on it, that pipe fitting was actually a quarter scale. And we were discussing it, and he's actually going to finish up just a little bigger scale than what we have there, maybe 3.2. But thought that'd be interesting to see that his original setup there. was using the machinable wax to get everything to scale and get all the problems worked out.